Okay, let's finish up section 3.2 by seeing another application of why radian measure is so important. This time we're not going to find the length of the arc, we're going to find the area of a sector. Now if you recall, think about when you order a pizza. Every time you order a pizza, you eat a slice of it. That slice, that section of that pizza is called a map, a sector. And you're not talking about then length around, you're talking about covering a space, a flat object, which is area. So that's what we're going to be talking about today, finding the area of a slice of a pizza, which is finding the area of a sector. So if you recall, let me show you where our formula is going to come from. It goes back to geometry. You should all recall how to find the area of a circle. What is the formula for area of a circle, everybody? You should know that's A equals pi r squared. Area is pi times the radius squared. So back in geometry, you learned how to find the area of a sector. You learned to write the formula by using it in degrees notation. Because what you said is this slice is part of the area of the circle. So you know the area of a circle is pi r squared, but you only want a piece of this. So suppose that angle was 90 degrees. That would be 90 degrees out of a total of what? 360. And 90 over 360 reduces to 1/4. So this area would be 1/4 of the whole circle. So back in geometry, this is how you wrote the formula. You wrote theta over 360 degrees. You said find the area of the whole circle and figure out what part of the circle you have, and that would be the area of your sector. Well, in trig, we now know if you can write an angle in degrees, you can also write it in what measurement? Radians. So let's come over here and convert 360 degrees to radians. How do you convert degrees to radians? You multiply by pi over 180. And the degree symbols are going to cancel out. And 360 divided by 180 is 2. So we know you can rewrite 360 degrees as 2 pi radians. So I'm going to take the same formula up here, and instead of writing theta over 360, I'm going to write theta over 2 pi. Doesn't that make sense? This angle is part of the circle. Part of the circle was 360 degrees in geometry. Part of the circle is 2 pi radians. And if I multiply that by pi r squared, we can now simplify this algebraically. Because look what happens. This pi in the numerator and this pi in the denominator will cancel. This is theta divided by 2. There's an invisible 1 in front of this. So this formula is written, area of a sector is 1/2, 1 over 2, theta r squared. Or we can rewrite that as 1/2 r squared theta. So guys, I don't just like giving you formulas and saying memorize them. There's a logic to where that formula came from. It came from taking the formula in geometry on how to find the area of a sector. And just by replacing degrees with radians, we have a new formula. Yes, you have to memorize that. Area of a sector is 1/2 r squared theta. Now all we're going to do is use that formula. Here's the catch again. R stands for what, y'all? Radius. A radius is a length measurement. So we're going to take that radius and multiply it to theta, which is an angle. Does that angle have to be in a certain unit? Yeah. It has to be in what measurement? That is right. Radian measure. So to work with this formula, your angle theta has to always be in radian measure because you want to multiply a number measurement of length times a number measurement of length. All right, let's work 3 examples in your notes. Let's go to 5A. So here's the picture. And the question says, find the area of the sector. So we first write the formula. Area of the sector is 1/2 r squared theta. All right, we want to find area. We want to know A. That's our unknown. How? Do we know our radius? Sure, in the picture it's 8. Do we know our theta? We got a problem. We don't know theta. It's unknown. It's still called theta. So we all know formulas are equations, And you can only solve an equation with missing one unknown. We have two unknowns here. So before we can find the area, we got to find theta first, the angle. Well, from the previous video, do we not have a formula to find theta? Sure we did. From the previous video, we know S equals R theta. What does S represent? The length of the arc. Well, there it is. The length of the arc is 4 pi. What does R represent? The radius. It's 8. So now, from the previous video, knowing this formula, we could find theta. We'll divide by 8. 4 over 8 reduces to 1/2. This is 1/2 pi equals theta. Now we could substitute it in. So area equals 1/2 8 squared times 1/2 pi. Be careful when you write 1/2 pi, the pi can either be in the middle of the fraction bar or up in the numerator. It is not in the denominator. So be careful of that. Just so you all remember, what's another way to write 1/2 pi? I could also write that as pi over 2. Multiplying by the half is the same thing as dividing by 2. If you prefer to have the pi symbol in the numerator, put it in the numerator so you don't make a mistake. All right, anyway, go back here to our area formula. We're going to perform order of operations. We're going to do exponents first. What is 8 squared? Good. It's 64, so we have 1/2 times 64 times 1/2 pi. I'm going to do half of 64 because that's easy. Half of 64, I believe, is 32. So that's 32 times 1/2 pi. This is 32 times a half, which is the same thing as half of 32. What's half of 32, sweethearts? That's 16. So this area is 16 pi. Now, because it's area, we need a unit behind it. Inches, feet, or centimeters. There is no unit, so we write the word units. But because it's area, we write units squared. So don't forget to put your square when it's area. Okay? Because you did a radius times a radius, which is a radius squared. All right, let's go to 5b. They give me R, they give me theta, and they want the area to the nearest tenth. So again, I write my formula. Area equals 1/2 R squared theta. The more you say the formula aloud, the quicker you'll memorize it. You substitute in 1/2. We know the radius. It's this decimal. 12 7/10 squared. We know our theta. It's 81 degrees. Here's our boo-boo. You're all going to want to jump and type that into the calculator. Can you take an angle in degrees and multiply it to the radius? No, you cannot. So you've got to come over to the side and do your work. So we're going to go over to the side and say, okay, we learned. How do you change degrees into radian measure? To change 81 degrees into radian measure, you're going to do pi over 180. Now I know what you're saying. There's nothing to cancel with the pi, and 81 and 180, I don't want to reduce it. You can leave it just like that. You're about to type this all in the calculator anyway. So area equals 1/2 12 7/10 squared times 81 pi divided by 180. If you want to reduce the 81 and 180, you can, but you don't have to. We're going to type this in exactly as we see it. Now, let's learn about typing our calculator. If you leave the 1/2 as a fraction, then it needs to go in parentheses. So you'd have to do open parentheses, 1 divided by 2, close parentheses, times the next thing. I prefer it to be a decimal. So I'm going to change 1/2 to the decimal 5/10. So I'm going to have 5/10 times 12 7/10 squared times 81 pi divided by 180. You don't need to use the multiplication symbol because if you keep everything in parentheses, the calculator will know to multiply. So I'm going to type 5/10, open parentheses, 12 7/10, close the parentheses, hit my square button. Then I'm going to type open parentheses, 81, put the pi button right next to it, divide by 180, and then close it. So let me show you. Slow. Let me get it up there. So see the 5/10, the 12.7 squared? And here comes the 81 pi divided by 180, close it. If I type it exactly as I see it here, it will give me the exact answer. And I will get area equals 114.00918828. A stands for what word, guys? Area. Is area in radians? Heck no. Only thing in radians would be theta, an angle. We didn't find theta. We found area. It says to round this to the nearest tenth. Zero's in the tenth spot. There's a zero behind it. So this would be 114.0. They gave us a unit up here, centimeters, so we would write centimeters squared. Make sense? Good. Let's do one more example in this set of notes. Let's go to example 6. So here's the information they give you. A is 16 inches squared. They give you R is 3 inches. They say find theta. Okay, so we have an A and an R. So our formula is A equals 1/2 R squared theta. We know what A is this time, 16. 1/2. We know what R is this time, 3. We don't know theta. Okay, so we have one unknown, so we'll do our work. 16 equals, you can't do 1/2 of 3 till you square it first. So what is 3 squared, y'all? 9. We can do 1/2 of 9. Now, I prefer 1/2 of 9 as a decimal. 1/2 of 9 is 4.5, right? 4 5/10 times theta. This is easy. To get theta by itself, divide by 4.5. 4 5/10. Gotta love technology and calculators. Let's do that out. So 16 divided by 4 5/10 would be theta equals 3.555555556. Now you're going to say, oh, this decimal ends. No, it doesn't end. It filled in the whole screen. What you'll notice about this decimal, it has a pattern to it. The 5 is repeating. The only reason why there's a 6 at the end is because you ran out of space and the calculator automatically rounds. So this is really the decimal, 3.5 with a repeating part. Now, here's the problem. We've solved for what? Theta. Theta is a what, people? It's an angle measurement. Is this degrees? I don't see any degree symbol in all that work. Don't you dare put a degree symbol. So that means this angle's in what measurement? Radians. If it makes you happy, write the R, word radians behind it so you know it's in radian measure. That's fine by me. You don't need to. I understand if theta is a number, it's in radian measure. Now it asks to change this into decimal degrees. Well, the first thing you got to do is change this from radians to degrees. So you have to do your conversion. Here's the boo-boo. You cannot just use 3.5, 3 5/10. You have to use the whole radian measure. So keep it in your screen. So you want to take 3.555555556, and to change that into degrees, you want to multiply that to, what's your conversion, people? To change it to degrees, you're going to multiply by 180 over pi. So keep the whole decimal in there and hit multiply by 180 divided by pi. And hit equals, and here comes your decimal degrees. So theta is 203 and 7183272. That's degrees. See in my conversion, there's a degree symbol, so put the degree symbol. Now, I believe the homework said to round that to the nearest tenth. So 7 is in the tenths. It would stay a 7 because there's a 1 behind it. So this is approximately 203 7/10 degrees. Okay? Now it says change it to DMS. We all know how to do that. We just got to get the DMS button. So everybody, again, don't just use this rounded answer to get DMS. Your minutes and seconds will be off. Use the whole decimal degrees. So there's the whole decimal degrees in there. And go get your DMS button. And hit equals, and you're going to get is decimal degrees. 203 degrees, 43 minutes, 6 seconds. And it said to keep it in DMS form, so it wants degrees, minutes, seconds. There it is exactly. So what we have found out in this first section is that angles can be measured in degrees and angles also can be measured in radians. We found out again why radian measure is important. If we're doing a calculation with a formula and we want to take an angle measurement and multiply it to another number, that angle measurement has to be as a number, which is why we need a radian measure. Just to let you all know, we haven't done any trigonometry yet. There has been no talk about trig because I haven't thrown you a trig word yet. All we've done so far in all these videos is expand your knowledge of angles, which is expanding geometry. So when I see you next, in the next section, we will finally get to begin trigonometry. Have a great day.